Hey guys, welcome to lesson 2.3, factoring. Students will be able to factor quadratics completely by finding the GCF, the greatest common factor, and using the difference of square. So, in the study of algebra, there are certain skills that are called like your getaway skill, because without them, students cannot enter into many more complex and interesting problems. Perhaps the most important getaway skill is factoring. So there are two definitions for factoring. So factor as a verb means to rewrite a quantity as an equivalent product, or if factor is a noun, an individual component of a product. A prime number is an integer greater than 1 which is divisible by only 1 in itself and by no other positive integers. So just a quick vocabulary word we need to know. A few prime numbers are 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, and 37. There's a lot more. So the first thing that I want to look at today is for each of the following integers, completely. In other words, I want you to write these numbers as a product of only prime numbers, which you all know are called prime factorization. Most of you remember the factor tree, so I want to use the factor tree to break these down. So what I do is we find two numbers that multiply to give you 12. We know it's 6 and 2. 2 is a prime number, so I circle it. I know 6 can be 3 and 2. So when I write a number about in terms of prime factorization, 12 is the same thing as 3 times 2 times 2. And this is what it means to break a number down in terms of prime factorization. So let's do 30. And remember, there's a lot of different ways. Like you can do 10 times 3. You can do 6 times 5. It's up to however you want to do it. You'll get the same answer. So 10 times 3, 3 is prime. 5 can be broken down as to 5 times 2. So 30 is the same as 5 times 3. Sorry, what did I write? 5 times 3 times 2. Let's try 16. We know 16 is 4 times 4. 4 can be broken down as to 2 times 2, and these 2's are prime number. So 16 is actually 2 times 2 times 2 times 2. Perfect. 36, piece of cake, is 6 times 6. 6 is 3, which is prime. 3 times 2, again, 6 is 3 times 2. So 36 is actually 3 times 2 times 3 times 2. Okay, so that's what it means to break number down into prime factorization. Finding our greatest common factor. So I want to rewrite each of the following binomials. Remember, binomial means it has two terms as a product of an integer with a different binomial. So what I want to do is break these down. 5x, 5 is prime, so it's 5 times x, and 10 is actually 2 times 5. They have a 5 in common, so I take that out, and then what's left over? I have an x, and the plus is because it's plus up here, and then a 2 is left over. So this is when I rewrite it in terms of finding the GCF. I pulled out what they have in common, and then I look for what's left over. 2x I know is 2 times x, and 6 is 3 times 2. I always want to break these down in terms of prime factorization. They have a 2 in common, so I take the 2 out, and x is left over, minus, because that's what I'm using up here, and a 3 is left over. So one quick way to check this is if you were to distribute this to, would I get what I started with? That's my point. Let's see, 6x, I know 6 is 3 times 2 times x, and 15 is 5 times 3. They have a 3 in common, So I take the 3 out. What's left over? 2 and an x. So 2 times x is 2x plus, and a 5 is left over. Bam. Let's see, 6 is 3 times 2. 14 is 7 times 2. Oh, it's 14x. So let's write it. 14x is 7 times 2 times x. They have a 2 in common. Take the 2 out. 3 is left over, minus a 7 and an x. So a 7x. Now, if they had two numbers in common, I will just multiply the numbers, just out there, okay? So, our third example says, write each of the following binomial as a product of a binomial's GCF and another binomial. All it's saying is to break these down and look for what they have in common, and I want to try to factor these out. So, 3x squared, I know 3 is prime and x squared is x times x. 6x is 3 times 2 times x. They have a 3 in common, and they have an x in common. So I'm going to take the 3x outside, and x is left over, plus the 2. Remember, how do I know what sign to put here? It comes from the top here, okay? Let's try these. 20x. 20 I know is 5 times 2 times 2 times x. If you're not sure, just do 20 is 10 times 2 and then 5 times 2, okay? If you're not sure how to break these down. 5x squared, I know 5 is prime, and then x squared is x times x. They have an x in common, and they have a 5 in common. So I'm going to take the 5x out. They have two 2's in common. So this is what I mean. When they have two numbers, all I'm going to do is 2 times 2, which is 4, minus, and then they have the last x there. 10x squared is 5 times 2 times x times x. 25x is 5 times 5 times x. I see an x in common, I see a 5 in common. So again, 5x is in common, 2x is left over, plus 5. And remember, the key thing is if I distribute these back over, if I was to distribute the 5x to the 2x and the 5x to the 5, would I get this back that I started with, okay? That's your key way of checking, are you correct? 4 says, rewritten in factored form, 20x squared minus 36x is equivalent to which of the following? So, show work here. So, 20x squared. 20 broken down is 2 times 10. 10 is broken down into 5 times 2. And I like to circle my prime numbers. So 20 is 5 times 2 times 2. X squared means x times x. 36x I know is 6 times 6. So 36 I know is 6 times 6, and 6 is broken down into 3 times 2. So this becomes 3 times 2 times 3 times 2 times x. So they have an x in common, they have a 2 in common, and they have another 2 in common. So since they have two numbers in common, I know I'm going to say 2 times 2 is 4, and they have an x in common. What's left over? So let's see what's left over. A 5 and an x, so 5x minus what's left over here, a 3 and a 3, and 3 times 3 is 9. Remember, when you have two numbers, you multiply it, so the answer choice is choice number 2. Okay? Very important is trinomials can also sometimes be factored into product of the GCF and another trinomial. So just like what we did when we factor binomial, we factored out the greatest common factor, we still had a binomial. Trinomials are same exact thing. Now, what I want to do is 2x squared is the same as 2 times x times x. 8x is the same as 2 times 2 times 2 times x. And 10 I know is 5 times 2. So if you're not sure, break 8 down is 4 times 2. 2 is prime, and 4 is 2 times 2. So I can do this in my head. If you need to write it out, of course you can do that, okay? So when I do this, I need to look for what all three of these have in common, okay? Not just one of them, not just two of them, all three. So I see there's 2x here, this doesn't have an x, but I see that they all have a 2 in common. So that's what I factored out. What's left over? X times x, which is x squared, plus a 2, and an x. So this becomes 4x plus 5. And that's it. That's all I do when I factor a trinomial as a product of its GCF and another trinomial. Remember, trinomial means 3 terms. Okay, so it means I have a GCF and then there's another trinomial inside there, okay? Now let's look at our second example. 10x squared. You have to take every term and break them down. Okay, so 10 is 5 times 2 times x times x. 20 is 5 times 2 times 2 times x. And then 5 is already prime. So I look at this. They all have a 5 in common. All three terms have to have the number. So what's left over? 2x squared minus 4x plus 1. Since this has nothing left over, I can't put 0 because remember, my goal is if I was to distribute this over, I have to start with what I got there, okay? So again, these minus and plus sign comes from my original equation. Whatever is in my original equation, that's what I want to work with. Moving along to C, I want to take every term again. 8 to the third, 12x squared, 20x. 8 is 2 times 2 times 2 times x times x times x. So really quick, I'm going to write it here and then take it off. 8 broken down is 2 times 4, and then 4 is 2 times 2. So that's where that came from. 12 is 4 times 3. 3 is prime, and then this becomes 2 times 2. So 12 is actually 3 times 2 times 2 times x squared. 20 broken down is 2 times 10. 10 can be broken down as 5 times 2. Remember, when I'm breaking these down, I want it to be prime factorization, okay? This becomes 2 times 5 times 2 times x, okay? So, what do these have in common? Let's look for what they have in common. I see they all have a 2 in common, and they all have an x in common. So when I'm going to factor, oh, they'll have another 2 in common. So they have two 2's in common, okay? So when they have two 2's in common, remember I said you multiply this. So it becomes 2 times 2, which is 4, and they have an x. What's left over? Let's use a different color so we can see what's left over. I see a 2, and then I have two x's, so that's 2x squared minus a 3 and an x, 3x plus, and then what is left over? 5. So this is my answer. If I take this and multiply, 4 times 2 is 8x to the third, 12x squared, 20. Remember, if you distribute these over to every single term, are you getting this? Okay? The last example, but before that, let me take these that I did off. There we go. Now, let's take every term. 6x to the third, which we know is 3 times 2 times x times x times x. 15x squared, we know is 5. 3 is 15. X times x, and 21 is 7 times 3. It's actually 21x times x. Now, what do these have in common? These actually have a 3 in common, yep. These have also an x in common. Anything else? Remember, all three of them have to have the same thing in common. So this becomes 3x. What's left over? 2x squared plus 5x minus 7. And that's my final answer. So remember we talked about conjugates earlier. When we multiply conjugates, what do? When we had a plus and minus, we just square the terms. These are what I talked about called the difference of perfect square. So the key is to get something where all the exponents are square, and then I kind of branch it off. So write the following binomial as product of the conjugate. So to get something, notice I have here x squared minus 9. I want to rewrite this so they all have a square exponent. So the way I do that is just take the square root of the number that doesn't have a square inside. So I can rewrite this as x squared minus 3 squared, because I know the square root of 9 is 3, so I write it as 3 squared. And when I factor that out, it's going to be x minus 3 and x plus 3. That's it. Remember, conjugate pair that we talked about in our previous lesson. So I want to take the square root of 4. This becomes 2 squared minus x squared. So when I branch that off, 2 minus x and 2 plus x. Same goes. Take the square root of all the numbers. My key is to get them with both squares. This becomes 2 squared x squared minus 5 squared. Branch them off. 2x minus 5, 2x plus 5. And then the last one, remember, key is to break these up. This becomes 4 squared minus 9 squared x squared. Now they all have squares. 4 minus 9x and 4 plus 9x. Number exercise 7 is very, very much similar. Square this. So I can rewrite this as x squared minus 1 half, no, sorry, x squared minus, so here we were saying, sorry about that, we have x squared, we take the square root of that, it'll be minus 1 over 2 squared. Remember, this is the same as 1 squared, so when I write this off, it'll be x minus 1 half, x plus 1 half. Try the second one. Square root all of those numbers that doesn't have. Remember, these are perfect squares. So 5 squared minus x squared over 3 squared. And I want to branch these off. 5 minus x over 3, 5 plus x over 3. Take the square root of every numbers here. Whoa, there's 4 numbers here. So this becomes 2 squared over 9 squared x squared minus 7 squared over 3 squared. Branch these off. 2 over 9x minus 7 over 3 and 2 over 9x plus 7 over 3. And then the last one we're going to do is take the square root of these ones. 6 squared x squared minus 7 squared y squared. So we have 6x minus 7y and 6x plus 7y. Okay, so you have to remember this is like your key thing when you're doing a conjugate multiplication. So I want to factor out completely. Factoring an expression until it cannot factor anymore, that's what's called factor completely. So the last thing that I want to talk about is we're going to combine our GCF and difference of square to factor these example completely. Okay, so the first thing I need to look at is what's the GCF here. So 5x squared and 20. I know 5 times x and 20 is 5 times 2 times 2. So they have 5 in common. So this becomes 5x squared minus 4. So remember we said we can rewrite this as 5x squared minus 2 squared. And then I'm going to branch this off. So what I'll do is change the color. This becomes 5x minus 2 x plus 2. And this is where you factor until you can't go any further. That's what it means to factor completely. Okay, so again, exercise letter B, 28x and 7. What I want to do is 7 times 2 times 2 times x, and this is 7. What am I left with? They have a 7 in common, so I take the 7 out and I'm left with 4x squared minus 1. Remember, when nothing is left over, is 1. And I can rewrite this as 7, 2 squared, x squared minus 1 squared. You take the square root of these numbers. And then my final answer would be the 7 that's outside, and then this is a difference of square that we talked about. So it could be 2x minus 1 and 2x plus 1. Remember those conjugate pairs, okay? Perfect. Now let's go to C and D, our last two examples. This becomes 40 is 5 times 2 times 2 times 2, and 250 is going to be broken down as, here we go, so 250, I did it here for you, is 5 times 2 times 5 times 5, and it's actually 250x squared, so that's x times x. They have a 5 in common, they have a 2 in common, so this becomes 10, 4 minus 25x squared. And if I break these down, I know I can rewrite this as 10, 2 squared minus 5 squared x squared. See? No middle term, no b term, and then it's minus, so conjugate multiplication, 2 minus 5x and 2 plus 5x, and that's my final answer. How about if you pause the video and try the last one on your own and tell me what you got? Well, great. Great that you got a chance to try this. Let's see if we got the same answer. Did you get 3x, x minus 4, and x plus 4? Excellent work. So that's our end of factoring with GCF and difference of square.